Edwin Chen is a data scientist and blogger. He previously led data science at Dropbox and Google. Edwin, welcome to Software Engineering Daily.
Thank you. It's good to be here.
We've done a few shows giving an overview of what data science is. For this episode, I'd like to focus on what a data scientist does. You were the head of core data science at Google. What were your responsibilities there?
Yep. So my typical day-to-day would involve a couple of different things. So one large chunk of it would be on my own work. And so just to elaborate a little bit more, by core data science at Google, I focused on search and discovery at YouTube, like analyzing the effect of our infrastructure, and then a lot of like cross-functional data science, things like crowdsourcing and visualization. And so one large chunk of it would be my own work. So I might be writing a MapReduce job to pull data for some analysis I might be working on. I might be presenting this analysis to a bunch of different teams that might find it useful, or I might just be running some different machine learning algorithms to, say, improve YouTube recommendations or to improve CTR on the Google Play Store.
So was that a management role, or was it more of a actual heads-down analytics role?
So it's a little bit of both. So I would say I probably focused more on my own technical work rather than purely on managerial stuff, which a lot of other people do. For me personally, it was, I guess, a mixture of both focusing on my own individual contributions and then just helping out my team a lot.
The base level of a Google data science track is Quantitative Analyst 2, and you've written about this a bit. What type of work is this level of engineer doing?
At Google, at least, it really depends on the team that you're working in. So Google has a couple different quantitative analyst / data science teams. For example, ads, Google Ads has a couple different teams. Google Search has, I think, 2 different teams. YouTube has its own team. Google Plus has its own team. And they all kind of do different kinds of work depending on what's most useful to their org. So, for example, the people in Google Ads, they tend to be a little bit more like the classical statistician. So they'll be doing things like trying to predict CTR or coming up with better objective functions to maximize happiness between users and advertisers. And so in general, they're probably very, very good statisticians, very hardcore statisticians. In contrast, at somewhere like YouTube, we were less focused on hardcore statistics and more on things like user analysis and business intelligence. And so the people who worked on quantitative analysis at YouTube might be a little bit less well-versed statistically, or they might come from different backgrounds than what a classical statistician would come from, but they'd be focusing a little bit more on user analysis or working on products or working with product managers, stuff like that.
Did these entry-level data scientists at Google have to know technologies beyond SQL? Did they have to know how to run MapReduce jobs?
Not necessarily. There are definitely a lot of people, like most people actually, who come into Google. They've never written a MapReduce job before. So whereas you might be asked if you know what the concept of MapReduce is in an interview, and you might kind of be expected to know generally what MapReduce is and how it works. You're definitely not expected to have had any experience writing it before.
Is the interview process for the data science type roles the same as it is for software engineers?
No. There are 2 different ladders. So one is a software engineering ladder, and so you'll be tested on typical software engineering things like algorithms or distributed systems, stuff like that. And then there's a separate ladder called the quantitative analysis ladder, and they ask totally different questions. So these will be things like more stats questions, or maybe asking you if you know how to write SQL, stuff like that.
Are both of those types of interview tracks whiteboarding, like the high-pressure whiteboarding situations?
It really depends on your interviewer. So most interviewers do prefer whiteboarding, but there are actually some interviewers who will like give you a laptop and ask you to code on that instead.
What are your thoughts on the types of high pressure whiteboarding jobs, or just like, even on the laptop, you're brought in, you got the 45-minute session with the interviewer to do the interview under pressure. Do you think that makes sense for interviews?
Uh, yeah. So I admit I never ask any whiteboarding questions myself, or I never ask any whiteboard coding questions myself. Like occasionally I'll ask someone a whiteboarding question that involves them like some math or just to write something down. But whenever I ask any coding questions, I'll just give them a laptop and ask them to code up that. Um, so I definitely prefer giving people a laptop when possible so that you can actually write something and see if it runs. And I do like a lot of companies nowadays, they're doing something where for their data science candidates, they'll give them an actual data set. And like they'll give them, instead of just like a 45-minute interview, they'll give them like a couple hours to like go through the data set and like come up with some useful algorithm or some useful analysis. So I really like that idea.
So on the other end of the ladder, from the introductory data scientist or quantitative analyst, there's the principal quantitative analyst. And you wrote a quote in one of your posts where you said there were a few principal quantitative analysts at Google who couldn't tell you what Bayes' theorem was or even what a CSV file or MapReduce was. Does this say anything about like our preconceived notions of data scientists, or like what the benchmarks for a data scientist should or shouldn't be?
Um, yeah, so I think what this says is more about so I definitely think that pretty much any quantitative analyst should, or a data scientist should know like what a CSV file is, and they should know basic statistics. Um, like it's like whenever you're doing any kind of work, you're obviously going to be manipulating data files and CSV files, and if you don't know any like relevant statistics, it's hard to know whether your analyses are correct and rigorous. And so I think I think this was actually a flaw of Google in that there were just so many politics going on, and especially with a lot of Aqua hires Google made, it definitely lowered the bar for a lot of people it hired.
Interesting. Um, so so you're saying that, like, an acqui-hire would happen, and somebody who is getting acquired, like, that you don't have a good role for him, so you stick them in the principal quantitative analyst role, and then it dilutes the quality of principal quantitative analyst?
Correct. Like the way a lot of acqui-hires work, I guess it kind of depends on the company, but you're not always judged at you don't necessarily pass the same like rigorous interviewing process that other people do, and so a lot of times you just like kind of get to slip through if you're part of an acqui-hire.
Could you dissect a difficult data science problem that you encountered while you were at Google?
So one of the data science problems I worked on at Google was the question of how do you get people to increase their YouTube usage. So maybe someone like watches YouTube 1 or 2 times a week, or maybe they only watch YouTube whenever someone sends them an email containing like a cat video. And so how do you like turn them into someone who starts watching YouTube every day? And this is a hard problem because it's kind of getting at the notion of causality and interventions. Like we want to do something that causes you to return more, whereas all the data that we have in the logs, it's just purely correlational. So we know how people who come to YouTube every day differ. Like they tend to watch a lot more music videos. They tend to watch a lot of gaming videos. Whereas someone who only comes to YouTube 1 or 2 times a month might only be watching like funny cat videos or funny dog videos. But that's like purely correlational. If we send emails to people who only watch cat videos, telling them that they should watch like StarCraft or League of Legends or just like random gaming videos, like that's not going to really cause them to come to YouTube every day. And so like how do this is like a very difficult question because it's hard to distinguish between causality and correlation. Like even though everybody says correlation is obviously not causation, it's like it's kind of like a meaningless statement that doesn't like really help you figure out what does lead to causation.
Interesting. What other misconceptions do you think people have about correlation versus causation?
I mean, I've definitely seen like it happen over and over again. That people will just like present correlational findings and try to use them as a as something that the company should do. Let me give an example. So I remember someone else on a different team at YouTube. Um, they were trying to figure out what their team should work on, and so what they basically said was, if we look at people who watch YouTube every day, they tend to watch like 10 channels or like more diverse channels than people who only come to YouTube once or twice a week. And so this is kind of like, like very obvious. Like obviously, if you watch YouTube more, then you're more likely to be watching more and more channels. Um, and it doesn't really like it's kind of like obvious enough and like obviously not causational causational enough that it doesn't really help you at all. And so they were trying to use this um, as a reason for basically just sending people more and more emails, introducing them to like new artists and new YouTube creators that they've never heard of before. And so at the end of it, they kind of just said, yeah, but yeah, we know that correlation is not causation. But they just ended up presenting this analysis anyway and using it as a reason to basically do whatever they wanted. So I think that the gist of that is like people will say that correlation is not causation, but they'll kind of just
Act
use
differently.
that. Yeah, they'll like just totally act differently and say it as kind of like a throwaway comment.
Right. So
That-
before Google, you worked on ads quality at Twitter. What is ad quality, and how do you strive to pursue it?
So ad quality refers to the question of how do you match users with high quality relevant ads. So this would be things like the machine learning systems to predict ad click-through rates, be the systems to run advertising auctions to figure out which ads are the winning ads that we should show to users, and stuff like that.
How big of a problem are bots?
So bots weren't a huge problem when I was at Twitter, but it was still big enough and potentially big enough in the future that there was a team dedicated specifically to preventing advertising spam and fraud.
Is the battle with advertising bots similar to the classic war of attrition between like email spammers and Gmail anti-spam filters?
Uh, yeah, I would imagine so. I did not work on the advertising bot problem myself
Hmm.
when I was at Twitter, so I don't know much about it, but I think so. And so I mean, I guess the problem with bots is that in ads is that you'll just have bots who are randomly clicking on ads. So you might click on ads on your competitors in order to like get them to have to pay up for these empty ad clicks that don't actually generate any value for them. Um, and so I guess it's yeah, kind of analogous to email in that.
Okay, well, as far as things you actually did work on, what are some engineering tactics that you used to ensure ad quality? Some tactics around data science.
So we had a lot of machine learning systems. So our machine learning systems were separated into two parts. One part of it would simply be to find candidate ads. So the idea is, we might have like a million ads in our system, but in order to reduce the set of candidate ads we might show you, we want to narrow this down to like 100 or 1,000 ads first. So one part of our machine learning systems would be to simply narrow down the entire set of like a million ads to 100 or a couple hundred. So that's one part. And then the second part would be to take these candidate ads and to predict their CTR. So given a user and an ad, we would feed this into our machine learning systems to try to predict whether the user would click on the ad or not.
Okay. And so as far as your more recent work, you posted a product analysis of Airbnb's search and discovery process on your blog, and it's this really in-depth study of how Airbnb does certain flawed things in the search process and a kind of a proposal for ways it could be improved. And to be clear, you don't work at Airbnb, but what was your motivation for writing this post?
So my motivation for writing the post was, I guess, twofold. So one, I've worked on this kind of analysis at a lot of the other companies I've worked at. So I did this kind of analysis a lot when I was at Google, and I did a lot of this kind of analysis at Twitter, and I was just interested in applying it to Airbnb. Especially since I don't think a lot of people tend to think of doing this kind of analysis.
Yeah, can you describe your approach in more detail? It's pretty interesting.
So I think the problem with most, or with a lot of machine learning systems at different companies is that they'll analyze a search and discovery system, or they'll analyze their machine learning recommendations purely in terms of CTR. Like basically that's like one of the few, they'll just look at log metrics like CTR. But they don't really understand why CTR is high, or like what are problems that could be improved with the algorithm. And so one of the things I like to do is just ask users, like go to your YouTube recommendations or go to the search results you found the last time you tried to find an Airbnb listing, and just like rate them for me and tell me why they're good or bad. And so I find this really useful because one, it gives you a lot more data than you can get by simply looking at your logs. Like if you look at your logs, you don't really understand the reasons why someone didn't click on a video. Like the reason someone didn't click on a video or the reason someone didn't book a listing might not be because it was a bad listing or it was a bad video, but like maybe they just didn't have time at the like current moment to watch that video, or maybe they'd already seen the video before, or maybe it was like the Airbnb listing they found was too expensive. And so if you can ask like actual humans for all of the reasons they like or dislike one of the recommendations they get, it just gives you a lot more insight into what's wrong with your algorithm or what's good about it. And then based off of that insight, you can then like devise better hypotheses and better possible fixes to make in order to make your algorithm even better.
So you found a number of users and you got them to essentially go onto Airbnb, and you said, hey, like search for some places, imagine a vacation that you want to take, and try to find an Airbnb that would suit that vacation. What were the results of the data set that came back to you?
There are probably two big problems with Airbnb's search ranking algorithm as it currently stands. One is location. So like even if something like one example that I found was someone was trying to search for places to stay near Disneyland, so near Anaheim, California. But then for some reason, the Airbnb search algorithm was like returning the Airbnb listings like 50 miles away from Disneyland. And so like that's obviously one thing the search algorithm should take into account. Another one is keywords. So if you look at a lot of Airbnb search listings, the host will write something like, you can book this listing, but only if you stay here for a minimum of 3 days. And so there's like all this kind of textual stuff that the host says in the description that isn't part of any structured data set that Airbnb has. And so if you like, even if you're trying to search for a listing on Airbnb and you specify that you only want to stay like one night or 2 nights, you'll get in the search results these hosts who say that you need like a 3-day minimum. And so it's kind of analysis of descriptions or textual data is also something that's, I think, missing from Airbnb search.
So why is this a data science problem? Why is search and discovery a data science problem?
Yep. So I think search and discovery is like one of the canonical data science problems, just because there's so much potential for machine learning. And so whenever you have the potential for machine learning systems, it means that one, you need a lot of data in order to improve your machine learning systems. Two, like machine learning itself is obviously a data science problem. And then three, just because you have so much data and so many users interacting with search and discovery, that gives you that gives you even more data about these users. And data science can help understand what these users are doing and why.
From the perspective of the machine learning engineers on the side of Airbnb who are trying to improve this service, What can they do to improve it?
One thing they can do is just grab more features. So I mentioned, for example, that one of the problems with Airbnb search ranking algorithm as it currently stands is that it doesn't really understand what the host has written in the description about your listing. So it doesn't know if the host has specified that there's like a 3-day minimum stay. It doesn't know if like maybe the host has a lot of rules stating that no kids allowed or you need to clean up after yourself, stuff like that. And so if Airbnb could just grab more features about all of these listings, that would be super helpful. Um, so another area you can think about features is photos. So maybe people want to stay in listings that are really pretty or listings that are really clean. And so if Airbnb had more photo level features, that would, I think, help a lot as well.
How difficult is it to augment a search engine's pre-existing model with new features?
I would say it depends on how your search engine works. So if you have a machine learning system, if your search engine is purely machine learning based, then in some sense all you need to do is just add this as another feature into your black box machine learning search algorithm, and you're kind of done. It's still a challenge to gather all these features and make sure that they're correct and not noisy, and that you have the infrastructure to actually support learning and training over all these features. But if it's a black box machine learning system, it's kind of just another step. The problem is a lot of search engines are not purely machine learning based. Google's search engine, for example, is actually pretty famous for having relatively little machine learning. It's actually like very rule based, and has a lot of heuristic human involvement. And I think Airbnb as well. I think they've only recently started experimenting with making their search engine more and more machine learning based. So if it's not machine learning based, and if there are a lot of like heuristic rules involved, then adding another feature can be pretty complicated because it's kind of hard to tell how adding a new feature will affect the way your search engine currently behaves.
In this experiment, you also studied hotels versus Airbnb. What type of person tends to stay in a hotel despite their knowledge that Airbnb exists?
Yep. So I think there are a couple of reasons people prefer to stay in hotels sometimes. So one is simply for business travel. So business travelers often prefer to stay in hotels because it's easier. You can expense your hotel really easily. You're traveling a lot, so you don't have to go through the hassle of trying to find the perfect Airbnb listing every time, and you kind of just know what you're getting. Whereas Airbnb, it can be a bit uncertain about the quality. You don't know if your host is going to be there on time. You don't quite know if the pictures in the host listings are going to match up with what you actually find. You're pretty much guaranteed some level of quality with if you stay in a hotel. So I think business travelers for hotels a lot. Probably another one would just be people who are less budget conscious. So a lot of people who use Airbnb do it be a lot cheaper, especially if you're not booking an entire place to yourself.
Interesting. So you recently wrote a post on Quora about when A/B testing should not be trusted. When should we distrust A/B testing results?
Yeah, so there are a lot of cases, I think, when A/B, the results that you find when you run an A/B test at only 5 or 10%, they can differ pretty significantly from what you'll see when you launch the A/B test to 100% of users. So one example of that is ads. So oftentimes when we ran ads at Twitter, ran an A/B test on ads at Twitter to only 5 or 10% of our users, we might see something like a 30% increase in CTR or a 30% increase in revenue. But once we launched that to 100% of users, we'd actually see no gains at all. And so the reason for that was often because of budget effects. And so what this means is that when advertisers when advertisers choose to spend money on ads on Twitter or basically any other advertising system, they'll do something like say they only want to spend $1 million. So a problem that often arises is maybe your A/B test, when it's run on 10% of users, it uses up an advertiser's entire budget. So this particular algorithm, maybe when it was run on 10% of users, it only showed ads from this particular advertiser who had a really good CTR, and it didn't show ads from anyone else. And that's why it performed really well. But when you launch it to 100% of users, since the advertiser no longer has budget to expand beyond the A/B test user base, you basically kind of annul the effects of the advertiser.
And what's the solution to that problem?
Yeah, so the solution, it's one of the solutions at least, is to ramp up your A/B test kind of slowly. So instead of simply checking to see if your A/B test had really positive results when it was 5%, when it was launched to 5% of your user base, and then immediately launching it to 100% of users, if it did, you would do something like start with 5%. If that looks positive, then maybe ramp it up to like 15 or 20%. If that looks positive, then like maybe ramp it up to 50%. If that looks positive, then maybe ramp it up to like 99% and leave like a 1%, what's called a holdback. And then if that like seems to continue to be really positive, then finally you can launch it to like 100% of users.
Another example of A/B testing failure that you described is called cannibalization and crossover. You gave an example of how this can occur on a marketplace like Airbnb. Can you explain that example?
Yeah. So the idea of cannibalization, let me give you an example. So let's suppose that you're running an A/B test on Airbnb, and let's just say it's what it does is it simply lowers the price of every single listing in your experiment. And now let's suppose that we have a user Bob who would have bought a listing on Airbnb even if the price hadn't changed. But like now that he sees a lower price, he decides to buy something he decides to choose a listing from the experiment instead. And so even though he would have bought something in the basically in the non-experimental version of Airbnb, he buys it anyways. And so it looks like the experiment is basically positive, like it gets more bookings than the people who aren't in experiment, but it's only because it's cannibalized from the people who were not in experiment.
So to clarify, who exactly is being cannibalized in this example?
Yeah. So in this example, it would be the hosts.
Okay, like the control group.
Correct.
Okay, so what projects are you working on now? I think you left Dropbox recently. So what do you do with your time?
Yep. So I spend my time on a couple of different things. So one, I'm just working on various side projects. So I'm working on my own crowdsourcing platform, for example, where I'm building up basically building up a human computation platform. So whenever you need like thousands of humans to do a task for you, like whether it's data cleaning or whether it's to run surveys or whether it's to like call up a business for you, I'm kind of just working on building a service for that.
Is that like Mechanical Turk?
Correct. Like you can think of it as basically my own little Mechanical Turk platform.
What are the flaws of Mechanical Turk?
Yeah, so I think Mechanical Turk has quite a few flaws. So one is simply on the usability side. I think a lot of people who would want to use Mechanical Turk but they don't use it because it simply has like a really difficult and confusing interface. People don't know how to pay workers. Like you have to basically know HTML in order to even create a task, which is a huge barrier for a lot of people. And like even I myself, like I obviously know how to write HTML, but I hate running jobs on Mechanical Turk simply because I find it really annoying. So I think that just the usability is one aspect. Another one is spam. So I've talked to a lot of people who just can't get good quality on Mechanical Turk. Like I've seen people who've had to reject work on Mechanical Turk because like 50% of the responses to the content were spam. Like I myself, like I've seen cases where some of the tasks I've run myself have been like 20 to 30% spam, and I've just had to like throw out the data entirely. So I think that's another huge issue as well.
So can you tell me more about how you're building out your platform, like what the user experience is like and how you're architecting it?
I think the idea I'm going for is like let's say you know nothing about Mechanical Turk, or like you know nothing at all about who these people are, what they're doing, but you just have a spreadsheet in front of you. And so maybe this is a spreadsheet of like 1,000 businesses, and this is like the spreadsheet that you got from your sales team, or maybe this is like the spreadsheet of a list of like potential customers. And now what you want to do is like figure out their phone numbers. And so instead of the normal process of you having to download the spreadsheet as a CSV file, and then going to Mechanical Turk and then uploading that CSV file and then writing a bunch of instructions and then like creating some HTML and then like checking all this data for quality. What you kind of want to do is like you already have this spreadsheet in front of you, so all you should have to do is just click a button, and this spreadsheet will just get sent to like thousands of workers, and then another column in the spreadsheet will just get automatically filled out for you based off of their responses. And so you kind of never have to leave this spreadsheet at all.
Did you
And,
use this to do your Airbnb experiment?
yep. I use this to do that.
So to clarify how the user experience works, can you describe how you used it, what you were submitting, and what the workflow was like?
Yep. So what I did on Airbnb was I asked people uh, to to think about a place they wanted to travel to, and then they would search for that place on Airbnb and try to find a good listing. And so the way that worked on my end was I basically had a spreadsheet open, and I had like a couple different empty columns in it. Like one column was like where do you want to travel? Another column was like how good would you rate the first listing, and stuff like that. And so basically all I had to do was I just created the spreadsheet with these empty columns, and I just hit a button, and then this spreadsheet got kind of like fanned out to like hundreds of workers, and based off of the empty columns, they just filled out the spreadsheet for me.
Is the goal of this platform specifically to make it easier for data science teams to get training data?
I think that's one big application. So I've often had to do these things to like gather data on. So I remember when I was at Twitter, I built a gender classifier, and in order to get training data on like what gender users actually were, I used a system like this. So I definitely think training data for machine learning systems is one big application, but I think there are a lot more. For example, you can use this to do a lot of user research. Like sales teams often find this super useful because they need to find out contact information about their potential sales candidates. Um, and then you've probably seen like a lot of other startups or technologies popping up, like Facebook's or Magic or Operator, all of which kind of require this kind of human element to their technology. And so, like beyond just machine learning system itself, I think there are definitely a lot of applications.
Interesting. Do you think that is this like one end of the gradient of the gig economy?
Yep. That's how I think about it.
Interesting. What do you think is the ultimate economic effect of these types of platforms? Is that like too big of a question to ask?
Yeah. So I've been trying to think about a little bit about the economics as well. So it's definitely like very, very good for my workers. So a lot of people who work on my platform, they're people like stay-at-home moms who can't really get another job because they have to stay at home and watch their kid, or maybe they're like they recently suffered an injury, so like maybe someone broke their foot or and can't drive to work, and so like this is a good way for them to make money. Uh, and they couldn't really find any other job. So I think in that sense, it's very good economically. Um, it's kind of interesting to think about the differences between this and other like gig economies like Uber or Lyft or Instacart. And I think the difference there is that whereas Uber or Lyft or Instacart, they're like very localized in the sense that people in Chicago don't have to compete with people in India. You kind of do in this like purely online platform, and so it's like they're like I think interesting questions about how much you should pay workers, or how much workers should make when there aren't these like local real world physical barriers.
Is there a way to set up like a dynamic pricing system to aggressively get the prices to converge where they should be?
Um, yeah, it's a bit hard because I guess like because pricing affects quality so much, and because I guess there's also a difference between new workers and experienced workers. It's yeah, I think it's a little. I've experimented a little with trying to get price to converge, but it's something like very difficult and something I haven't quite solved yet.
You know, one thing I've thought about this problem a lot too, actually, and one potential solution I had was like if you get the workers in a situation where in order to gauge subjective situations, you force them to wager on things. So it basically gives them skin in the game. So no matter like what the, if there's a fixed payout, you make a dynamic payout also. So basically like if they say, if you're doing like a Turk task, like, hey, identify what's in this picture. And like the Turk is supposed to say, hey, that's a cat or whatever. That's technically a subjective thing. So you can say, how sure are you this is a cat? And the only way that they can ascribe how sure they are is they have to wager. So you have the quality built into the fact that they're wagering on it.
Oh, yep. That's pretty interesting. I think a lot of people actually do implement something kind of similar, where they'll like on Mechanical Turk at least they'll bonus people if they do particularly good work as a kind of way of making up for the fact that the baseline wage may not be great. Yeah, so it's definitely something that a lot of people do try.
Yeah, I think that's like it's like a prediction market. That's what people call it a lot of times.
Oh, yep.
So, you worked at Peter Thiel's fund, Clarium Capital. He has a saying, big data is often dumb data. Do you know what he means by that?
So I admit I actually have not heard him say that phrase before. So I don't know what he exactly means by that, but I would actually agree.
What would your interpretation be?
And so my interpretation is that, like, I actually found this like very, very true when I contrast my experience at Clarium versus my experience at Tech as well. It's that when you have a lot of data, you basically oftentimes don't try to do anything smart with it. Like you don't analyze it as deeply. You don't run as complicated algorithms. You're kind of a little bit less rigorous, and whereas you kind of get a little bit fancier. You analyze things more deeply when you have like relatively small amounts of data, and I think this is for two reasons. One is like oftentimes when you have like a lot of data, there are just so many possible things, like so many possible wins and so many possible like impactful things that you could do that there's kind of no need to go deeper. And the second reason is that like honestly, when you have a lot of data, you oftentimes can't really do anything fancy. Like it's just too expensive to run like complicated or fancier statistical algorithms when you have big data.
So do companies mostly have more data than they can actionably analyze these days?
I actually completely agree. It's not true of every single company. Like there are definitely some companies who don't have enough data, but like oftentimes, for example, when I was at Google, I would rarely run like MapReduce scripts over an entire user base. I would pretty much always sample it to just like 5 or 10% of users first, and that would be more than enough. And
So
yep.
is the solution to collect less data or to train more data scientists?
It's yeah, I guess a little bit of both. I definitely think some companies could be doing a lot more if they simply downsample their data so they were able to like work faster and iterate faster. Whereas a lot of companies, I think, like don't have like any data scientists at all, and so they could use more as well.
How do you identify the point of diminishing returns, like when you're collecting too much data?
Like if you like come like the interesting thing I find is that a lot of data science teams, if you ask them what their 10 most important questions are, or if you ask anyone else at the company, like what are the 10 things you wish you knew but you don't right now, a lot of people can't even come up with those. Like they have no idea what their 10 big questions are. They have no idea like what the 10 big like what the typical questions if they knew the answers to these questions. Like what are the 10 biggest questions that would drive the company most forward? Like most companies don't know that. And so if you don't even know what those questions are, then these data science teams, they're kind of just like working on like very like trivial, very meaningless questions. And so I think that's a sign that you've kind of like already drowned yourself in data and thought that like because you have so much data, you think that like any question will kind of be meaningful. But like really, yeah, you should just like collect less data and try to think of the more important questions first.
What are the 10 data sets you wish you had access to?
So I actually always say this. I still find like Twitter's data set the like my favorite data set in the world. Just because it's like it really is this kind of like window into the world. And whereas you could maybe kind of say the same thing as Facebook, I mean, you could definitely say the same thing as of Facebook as well. I kind of prefer the Twitter data set just because it's like so much more public. And so like anything you analyze with Twitter, you can kind of just like publish it like immediately without like huge privacy concerns. Whereas with Facebook, you know, like there's just because of like the privacy issues, there's a lot less you can do with it. Yeah, so
very
Twitter,
well structured too.
Yep, yeah, and yep. So I would say Twitter is definitely one of my favorite data sets.
Yeah, I actually saw some news article or interview with you where you said you were considering using the Twitter data feed to find out if people eat McDonald's when they're sad. Did you actually do that?
I did not. Yeah, I guess there was a lot of like really interesting analyses that I wish I'd done when I was at Twitter that I never had the time to do. And I totally wish I could do now.
Can you walk me through how you would do that? What would your process be?
Let's see. So if I was using Twitter to figure out if people eat McDonald's when they're sad, let's see. So I can think maybe I can think of two ways right now. So one way is to simply so at first I need to build some kind of like sentiment analysis classifier to see like whether a tweet is happy or sad. And so assuming I've built that already, I would then try to see if like people I guess like soon after a sad tweet or maybe like soon before a sad tweet, see if they do mention that they're eating at McDonald's more and see if there's a difference between like these kinds of McDonald's mentions around sad tweets compared to McDonald's mentions around happier tweets. So that's one way I would do it. Another way would be to try to use whatever geolocation data Twitter has. And so if I could somehow, I guess this would be kind of complicated, but if I could somehow like figure out, like find a map of McDonald's locations, I could see if like people are like checking in at McDonald's or tweeting from McDonald's when they're happier or sadder.
Interesting. Do you have any other like interesting stories of ad hoc Twitter analysis you've done?
Yep. So I actually like one of my favorite analyses is I was trying to see like whether Twitter could predict the election results. So this is like during the 2012 elections, and I was basically like counted all the tweets on the morning of election day, and counting like whether people were saying that they were voting for Obama or voting for I'm blanking right now. the guy who wasn't Obama.
Kane?
Yep. And yeah, and so I think that was really interesting because the results actually lined up really well with the overall electoral results.
Cool. So you seem to have enjoyed the companies that you've worked at, and that fascinates me because Personally, I've never worked a job that I've enjoyed. And so this may sound like a weird question, but how do you find joy as an employee?
Uh, yeah, I would definitely admit I've had my ups and downs as well. But I think for me, what I look for are a couple of different things. So one, just in terms of the work itself, like I like doing things where data is obviously like going to be super useful, and then where I think I can kind of like do these kinds of 10x projects. And so I admit I was actually a little bit unhappier when I was at Dropbox because I didn't find that people cared as much about data at Dropbox as I was hoping. But yeah, definitely at Twitter and Google, I think data was very strongly valued. So I think that's one key to being happy. And then kind of outside of data science itself, I guess just like working with like really cool people, really, people that you respect a lot. I find that is like a huge motivator as well.
What were the ways that you wish you could have used data more aggressively at Dropbox?
Um, so I think Dropbox is in a state where I guess two things. One, it doesn't know what products it should be building. And so I think data and user research can help a lot with that. And then two, doesn't, it hasn't thought strongly enough about the uh, whether the trends that have supported it until now are going to continue in the future. And what I mean by that is that people like turned to Dropbox initially because they wanted to basically collaborate with each other, or they wanted to back up their devices, or they wanted to sync their files across different devices. But that was like 6 years ago, and Dropbox doesn't really know whether that's a product trend that's going to continue in the future. And it also doesn't know whether that set of early users, like that set of early users might be very different from like the next 1 billion users that it needs to pursue. And it doesn't really know whether that's a different set of users or not.
Sounds like Twitter's problem.
Yep, exactly. I think Twitter and Dropbox share a lot of similarities, actually.
Maybe they should put Jack Dorsey in charge of Dropbox also.
Yep, he should be running 3 companies instead of 2.
Yeah. So a couple broad questions to close off. How will recommendation systems change our world in the near future?
One, I think, increasing trend that I've seen designers, interestingly, mention more and more, as opposed to data scientists, is the use of recommendations as a kind of filter for your life. So the idea is, we're bombarded with so much information that if we could, like, if our recommendation systems were good enough to just like filter all of the noise from us, so that we could just like focus on our lives without being distracted by all these like different things, I think that would be really interesting.
Is data science more of an art or a science?
um, I think it's both, in that like you definitely need a science behind it to make sure that anything you find and anything you try to convince others of is actually rigorous and hopefully true. And then it's an art in that like you need to be working on the right questions. Like a lot of data scientists I know, they kind of work on these questions that sound kind of cool, but which I think would never really have any impact on a product, and there's nothing really you can really do with that information. And so, in art, I think they're picking out the right questions that you should be trying to solve.
So, final question: who is the engineer that has impacted your life the most?
Let's see. So I would say, in terms of it's hard for me to pick out a single engineer, but there were a couple engineers I knew at Twitter, who I really have a huge respect for, and that I think I learned a lot from. And so these would be Avi Bryant and Oscar Boygan. And
Cool.
so I think I learned a lot from them, and they're really good engineers.
All right. Well, Edwin Chen, thanks for coming on to Software Engineering Daily. It's been really enlightening talking to you.
Yep. It was a pleasure talking to you as well.